Hello friends, today I am going to talk about units and dimensions. I have taken few questions from past year paper A-level physics 9702. Along with the solutions of the questions, I will also discuss the concept of unit and dimension in brief. So welcome to my channel sonisinghphysics. Friends, I am getting suggestions regarding the topics which I can take for my videos. Many thanks for that. Please keep writing either through the emails or in comments or through messages. Please hit the like button and subscribe to my channel. First is, what is unit? In order to measure a physical quantity, we need one standard. That standard is known as unit of that physical quantity. Basically, all the units are categorized into two: fundamental units and derived units. Fundamental units are the units of mass, length and time, whereas derived units are the units which is taken from mass, length and time, like the unit of acceleration, unit of velocity, unit of force, pressure, all those. There are four systems of unit to measure any physical quantity. The first one is CGS. In that, centimeter, gram and seconds are for respectively length, mass and time. The second one is FPS system, in which foot, pound and seconds are respectively for length, mass and time. The third one is MKS system, in which meter, kilogram and second are respectively for length, mass and time. The fourth one is SI unit. In SI units, there are 7 basic units: meter for length, kilogram for mass, second for time, kelvin for temperature, candela for luminous intensity, ampere for current and mole for amount of substance. In addition to this, there are 2 supplementary units: radian for plane angle and steradian for solid angle. Next is dimension. In order to obtain the units of physical quantity, the fundamental units are raised by powers, which represent its dimension. For example, if we write y is equal to kg raised to a, meter raised to b and second raised to c, then a, b, c are respectively dimensions of kg, meter and second. Let us move to question 1. Write down the dimension of Planck's constant. The formula for Planck's constant is energy by frequency. The unit of energy in terms of base unit is kg meter square per second square, and the unit for frequency is per second, because the formula for frequency is 1 by time period. So the Planck's constant will be equal to kg meter square per second square divided by per second. So when we solve it, we'll get the dimension kg meter square per second. This is the dimension of Planck's constant. Next question. This is a very important question and frequently asked in exams. The question is, dimension of a particle is represented by y is equal to at plus bt square plus ctq, where y is in meter and t is in second. What are the dimensions of A, B and C? So to solve this type of question, first we should see that what is the unit in left hand side. If you look at this equation, the unit for left hand side that is given in the question itself is meter. So what we will do in this equation? What should be the value of A, B and C? So the overall unit of right hand side should also be meter. So let's see that how we are going to do it. To get the dimension of constant A, B and C, we are going to follow this method. For constant A, the unit of left hand side is meter, so meter will be equal to A into second, and A will be equal to meter divided by second, that is meter per second. For B also we are following the same method. Meter will be equal to B into second square, so B will be equal to meter per second square. The same for C. Meter will be equal to C into second cube. So C will be equal to meter by second cube. So the value of the constant A meter per second, B meter per second square, and C meter per second cube. Now I will show that how we can check that our answer is correct. To check whether our answer is correct or not, we can follow this method. The constant A, B and C is meter per second square and meter per second cube. When we put these values in the equation, we can see that these are getting cancelled. So the overall unit of the right hand side will also be meter, whereas the left hand side was meter before. This is our third question. This question is from 9702, paper 1-2 from 2019, Feb-March. The question is, at temperature close to 0 Kelvin, the specific heat capacity C of a particular solid is given by C is equal to BTQ, that is the equation where T is temperature and B is a constant. The unit of specific heat capacity is given here, that is joule per kg per Kelvin. What is the unit of constant B? So that is our question. We have to find the unit of this constant B. These are the options given in the question and we have to select any one. This is the solution of this question. First we will take the equation over here, that is C is equal to BTQ, where B is equal to C by TQ. C is the specific heat capacity and T is temperature. This is the unit of C which is already given in the question, that is joule per kg per Kelvin, and now we have taken the SI unit of temperature, that is Kelvin, and as per this it is Kelvin Q. Now if you see the options, it is given in terms of meter and kilogram. Joule is not here. So we have to convert this joule in terms of meter and kilogram. The dimension of joule in terms of base unit is kg meter square per second square, that we have seen it before also. So when we write this unit over here, kg meter square per second square into per kg into per Kelvin divided by Kelvin raised to the power 3. So this kg and kg will get cancelled. So the dimension of B will be meter square per second square Kelvin raised to power minus 4. So our correct option will be B. This is our next question, and this question is from May-June 2019, paper 1-2. The question is, the Planck constant H has SI unit joule second. Which equation could be used to calculate Planck constant? So we have to choose from this which equation will have the unit joule second. So let's see that. Option A, Planck constant is equal to dE by V, where d is distance, E is energy and V is velocity. Unit of distance meter, unit of energy joule, and unit of velocity meter per second. Meter will get cancelled, so we will get the unit joule second. So this is the correct answer. Now we'll see why not B. If we look at B, Planck constant is equal to V by d, where V is the velocity, unit is meter per second divided by meter, that is distance. So we will left with per second. So this is a wrong option. The correct answer is A. This is our next question. Which expression gives an SI base quantity? So now we'll look at each option. The option A is charge per unit time, that is Q by T, and Q by T is a current. And current, we know that ampere is the SI unit of current and ampere is a base unit. So the correct answer is A. Friends, thanks for watching this video. If you have any doubt, please do comment.